We constantly use mathematics throughout chemistry to calculate quantities of chemicals that we will use. The most important thing is to learn the SI system. Scientists worldwide use common measurement units called the SI system or Standard International System. Look at this list for the physical quantities, the names, and the symbols of the units. You need to memorize this list except for the last one, the candela. We won't need that. The most surprising one is probably that mass is measured in kilograms, not gram. The gram is just too small. This next list shows the equivalence and conversion factors. You don't have to memorize anything from this list. We can always look it up. The thing to remember is every time you see an equivalent expression, a conversion factor can be made that is the fractional expression of those two equivalent values. For example, if we say 2.54 centimeters equals 1 inch, you can write that as the fraction 1 inch over 2.54 centimeters, or 2.54 centimeters over 1 inch. This is called a conversion factor. We use the SI prefixes in front of the SI units to show how many powers of 10 we are away from that unit. This is a big list. You don't have to memorize everything on this list, but I would say the most important things are the deca, deci, centi, milli, micro, nano, and pico. We will be using those throughout the year. Kilo and mega will sometimes also be used. Now the trick here is knowing that if we're talking about something like a microgram, which I know it looks like a UG, but actually it's the Greek letter mu looking like a cursive U. The microgram, 1 microgram is 10 to the negative 6 gram, because a microgram is 10 to the negative 6 times smaller. You could also express that as 10 to the power of 6 micrograms equals 1 gram, because it would take 1,000,000 of these little tiny micrograms equal to 1 gram. When you're writing a conversion factor, remember, you just want to make sure that the small number is with the big unit and the big number is with the small unit. So look at the two conversion factors and you can see 1 microgram, that's small number, big number, small unit, over 10 to the minus 6 gram, that's small number, big unit, or vice versa. Now, when we're converting, we're going to have to do mathematical expressions that always follow the order of answer equals given times conversion factors. Remember, conversion factors will always be written as fractions, and every conversion factor is going to have some kind of unit with the number. No naked numbers. We're not allowed to write just plain old numbers down without the units that say what they measure. We'll set up the conversion factor to cancel units to make sure they're in the right order. Let's try this as an example. We're going to convert 15 feet into meters. If we do that correctly, we'll start off by saying blank meters equals 15 feet. We do it that way because blank meters, that's the answer. 15 feet, that's the given bit of information. Then we start throwing in conversion factors. Well, one conversion factor is that 12 inches equals 1 foot. But we'll express it as a fraction, and we'll write it with foot on bottom, so that the 15 foot cancels with the 1 foot. The foot units will cancel. Likewise, we'll throw in the factor 1 meter equals 39.37 inches. Now, did I have that memorized? No, I had to look that one up. But we'll express it as a fraction and in such a way that the inches, one on top and one on bottom, will cancel. Our answer, 4.57 meters. Look at this second example. How many meters are in 1.25 feet? Your book expresses this answer using multiple conversion factors in much the same way. We will constantly do conversion factors and always set them up with the answer first, the given second, and then conversion factors as we need it after that to make things cancel. But remember, units must always be included with every number. No naked numbers. Occasionally we'll have to use volume. Volume is not an SI unit because volume is three-dimensional length. So one of the most common volume units, the liter, is really not an SI unit at all. The liter is actually 1 decimeter cubed. In the diagram, we remember 1 decimeter is 1/10 of a meter, or 10 centimeters. We can see this diagram looks like about the size of your hands if you balled up both hands as 2 fists. Since 1 decimeter is 10 centimeters, volumetrically we'll cube those unit lengths. 1 decimeter cubed is 10 centimeters cubed. 1 cubed is 1. 10 cubed is 1,000. there are 1,000 cubic centimeters in 1 decimeter cubed. We have another name for the cubic centimeter. We can call it the milliliter. So volume sometimes requires us think three-dimensionally. Let's put all these together and you try a conversion now. Convert the density of 2.6 ounces per cubic centimeter into the units of kilograms per liter. Let's start off by seeing if we can identify our conversion factors. First of all, I look at this and I think, we're dealing with ounces. One fact I know is that 1 ounce is 28.35 grams. I write that down thinking I might make a conversion factor out of that. 1 kilogram is 1,000 grams. That might also be very helpful. In the metric prefixes, 1 liter is 1,000 milliliters, and 1 milliliter is the same as 1 cubic centimeter. That might be helpful. Here's a tricky one. We don't have a conversion factor for cubic inches, but we do have a conversion factor for the inches to centimeters relationship. So 1 inch equals 2.54 centimeters. 1 cubic inch would equal 16.4 cubic centimeters, which is 2.54 cubed. We put these conversion factors together now to solve this problem. Starting off with our answer, how many kilograms per liter? Then we say, well, we're given 2.6 ounces per 1 cubic inch. Let's make ounces cancel out first. So I'm going to rewrite a conversion factor where ounces is on the bottom. 28.35 grams over 1 ounce. The number is really secondary to the unit. Always write your units first and then follow them with the numbers last. Now we need to make grams cancel. So write a second conversion factor with grams on the bottom. That'll make grams cancel. 1 kilogram over 1,000 grams. Now we need a conversion factor where inches cubed can cancel, and that's the one we have created out of inches and centimeters. Last thing we need to do is to make cubic centimeters cancel, so we use 1,000 cubic centimeters per 1 liter. We need to round off our answer to the same number of sig figs in the initial unit.